Slides to a stop. Distance, quiz 2024. A car is initially moving at a speed of 30 meters per second. The car accelerates at negative 1.5 meters per second and comes to a stop. What is the distance it travels? Assume uniform acceleration. Positive x is defined as to the right. So is it A, 150 meters, B, 225 meters, C, 75 meters, D, 300 meters? So what is the distance traveled during stopping? We are given the acceleration, negative 1.5 meters per second. That's how much your velocity is going to change. What is our final velocity? Once it comes to a stop, it is equal to 0. What about our initial velocity? We are told that it is going at 30 meters per second. So it is 30. We are asked for the displacement, delta x. So we know v final squared is equal to v initial squared plus 2a delta x. So from this equation, subtract v initial squared from both sides. So you get v final squared minus v initial squared is equal to 2a delta x. Divide both sides by 2a, and what do we get? V final squared minus v initial squared divided by 2a is equal to delta x. What is final velocity? 0. What is initial velocity? 30. So what is 30 squared? 900. And because of the negative sign, it will be negative 900. And at the bottom, what do we have? It is 2 times acceleration. Acceleration is negative 1.5. So what is 2 times negative 1.5? Negative 3. What is negative 900 divided by negative 3? 300 meters. After 300 meters, it will come to a stop. This is approach number 2. Distance traveled during stopping. Displacement is average velocity times time, but we don't know time. We do know the average velocity because final velocity plus initial velocity divided by 2 is your average velocity. Final velocity is 0. Initial velocity is 30 divided by 2, and so it is 15 meters per second. So you know your average velocity, but we don't know time. By definition, acceleration is equal to v final minus v initial divided by time. We know negative 1.5 is our acceleration. Final velocity is 0. Initial velocity is 30 divided by time, from which you can solve for t, and you will see it is negative 30 divided by negative 1.5, and that is 20 seconds. Once you have time is equal to 20 seconds, you have average velocity 15, and you have time, multiply the 2, and you should get 300 meters. So that's what I did here. Average acceleration is negative 1.5 meters per second. Average acceleration by definition is final velocity minus initial velocity divided by time. So you get negative 1.5 is equal to final velocity 0 minus initial velocity 30 divided by time, from which we can solve for time, and we get 20 seconds. So displacement is average velocity times time. Average velocity is 15 meters per second. For how long? Each second it travels 15 meters. That's our average velocity. So what is the displacement for 20 of those seconds? It will be 20 times 15, which is 300 meters. So please don't forget, average acceleration is final velocity minus initial velocity divided by time, from which you can solve for time, and we get time is equal to 20 seconds. So even though you're not asked for time, you still know how to get it. All right, how about we use displacement is equal to v0t plus 1/2 at squared. Do we know the initial velocity? Yes. Do we know the time? Yes. Do we know the acceleration? Yes. Do we know the time? Yes. So substitute all those numbers. Initial velocity is 30. Time is 20 seconds. Acceleration is negative 1.5. What about time? 20. Don't forget the square. So you have 20 squared. So 30 times 20 is 600. And what is 1/2 times negative 1.5 times 20 squared? 20 squared is 400. 400 times negative 1.5 is negative 600. Negative 600 divided by 2 is negative 300. So 600 minus 300, and the answer is 300 meters. And thank you. And this is George Mathew, trying to take care of you.